In this video, we're going to take a look at a two independent means example. A researcher with the Department of Education followed a cohort of students who graduated from high school in a certain year, monitoring the progress the students made towards completing a bachelor's degree. One aspect of his research was to determine whether students who first attended community college took longer to attain a bachelor's degree than those who immediately attended and remained at a four-year institution. The data in the table attached below summarize the results of his study. So we're going to complete parts A through E. So in this study, we're comparing two populations. So we want to make sure that it meets the requirements. If you're not sure what those are, check 11.3 textbook or notes. So the sample size has to be not more than 5% of the population. So notice the end, the 257 plus 1180, those are definitely not more than 5% of the population. The samples can be assumed to be random, so that's another requirement, is we have to have random samples. So we're going to assume that since the researcher was in the Department of Ed and followed a cohort, we're going to go ahead and assume it's a reliable source, so they're random. The sample sizes both have to be greater than or equal to 30. Our sample size are definitely greater than or equal to 30. The samples are independent. Yes, so we're going to assume independence because the samples are not more than 5% of the population. And we don't need E. The population doesn't need to be given as normally distributed because our sample sizes are large enough. So we want to perform a test. Does evidence suggest that community college transfer students take longer to attain a bachelor's degree? And use an alpha 0.1 level of significance. So we have to determine who we want to be sample 1 and who we want to be sample 2. So if we call this sample 1, the community college transfer, and sample 2, no transfer, then the population means are going to be mean 1 and mean 2. So n, this value is n1, this value is n2. Sample mean time, this is x bar 1, this will be x bar 2. Sample standard deviation time, this would be sample standard deviation 1, sample standard deviation 2. So we just want to identify which is population 1, which is or sample 1, which is sample 2, and population 1 and population 2. So this is what's going to let us write our null and alternative hypothesis. So the null hypothesis is that there is no difference in the times. Mean 1 is equal to mean 2. Okay, and again, these are completely independent samples, so we're not looking at differences between them. Okay, we're looking at difference in the population 1 and population 2, but they're not matched pairs. Okay, our alternative hypothesis is, I have to read it again. We want to know if students who first attended community college took longer to attain a bachelor's degree. So we want to know if mean 1 is greater than mean 2. So this type of test is a two-sample t-test. So on the calculator, stat over to tests, find the two-sample t-test. We don't have data, we have statistics. So the statistics are the means and the standard deviations. So we need to type in for the first sample, the sample mean, which was 5.36. Sample 1 standard deviation, which is 1.132. So this means that if attending community college first, it took them about 5.3 semesters to graduate with a mean of 1.132, and our sample size was 257. Now we do the same thing for population 2. Their mean was 4.44. So this is the group that didn't go to community college first. 1.014 is the standard deviation. So that means it took them a mean of 4.44 years. N2 is 1,180. Now we want to type in, is mean 1 greater than mean 2? So mean 1 greater than mean 2, enter. We're not going to pool our data, so hit no for pooled, and now we're ready to calculate. Wow, look at that. So we end up with a t, a test statistic, a very large t, 12.02, and the p-value is equal to, this makes me want to make sure I type that in right. Let's just double check and make sure I typed it in right. Two sample t-test, 5.36, 1.132, N1 is 257, 4.44, 1180. Yep, we typed it in right. So when you get numbers like that, it makes me wonder if I typed items in correctly. Okay, our p-value is 2.06 times 10 to the negative 28. So that's given in scientific notation. That means we're going to move the decimal back 28 times. So rounded to 4 places, the p-value is basically 0. So be careful on your calculator when it gives you a p-value that has to be a probability. Check and see if it's in scientific notation. Okay, so we've got our test statistic and our p-value is 0. Should the hypothesis be rejected? Yes, reject the null hypothesis. And what's our conclusion? The evidence does suggest that community college transfer students do take longer to attain a bachelor's degree at the 0.10 level of significance. And we rejected because the p-value of 0 was much less than the alpha level. So now we're going to take a look at a confidence interval. I'm using the confidence interval given in this homework problem. The confidence interval that goes with this test would be 80% because we have a 10% alpha and a left-tailed test. But I'm going to follow the directions and construct a 95% interval to approximate the mean additional time it takes. So the confidence interval is a 2-sample t-interval. Okay, so we still have the values in that we typed in before. And I want a confidence level of what the problem is asking for, which is 95%. Not pooled, and calculate. So I'm going to round it to 3 decimal places, 0.769 to 1.071. 0.769 to 1.071. So what does this mean? The confidence interval ranges. That means that I am 95% confident the difference in number of semesters between community college and, let's see, between community college first and not is between 0.77 and 1.07 semesters. What does that mean in English? That means it takes about 0.77 to 1.07 semesters longer if you go to community college first. All right, so that's how to use our calculator. And now using StatCrunch, we're going to use stat, t-stats. These are 2 samples with a summary, not with data. You're going to type in the sample mean, sample standard deviation for both samples, just like we did. So let me get the values again. Just need to move that out of the way. Okay, so the sample mean for sample 1 is 5.36, standard deviation 1.132, and then the sample size of the first sample is 257. Then we put in sample 2, a mean of 4.44, a sample standard deviation of 1.014, and a sample size of 1180. And either pool or not pool, so default is off. And our hypothesis test is mean is equal to 0. Alternative is mean is greater than 0. Click on compute, and we get the same test statistic and p-value. And to run the confidence interval, you use the same. Let me open that window. Maybe I can just change that real quick. What do I want? I want that sample summary. Okay. Then, no, I have to do the whole thing again. Okay. So then for stats, t-stats, go to to sample with summary, type your values in again, but down here, select confidence interval, type your confidence interval, and click on compute.